Hello and Assalamu alaikum. Today we have here Cambridge IGCSE Chemistry Paper 4-2 extended version, October-November 2021. Total time for which is 1 hour 15 minutes and total marks are 80. So question 1, this question is about states of matter. Complete the table using ticks and crosses to describe the properties of gases, liquids and solids. Okay, so the particles are furthest apart in gases and they do not touch. Whereas particles are not that far apart in liquid and they touch, whereas in solid they're closely, tightly, regularly arranged and closely packed. Particles have random movement. So in solids, of course, we know the particles only vibrate, they cannot move. And in liquids, they can move randomly, and so in gas. Regularly arranged, I just told you about solid that only solids are regularly arranged. Substances can change state. Boiling and evaporation are two ways in which a liquid changes into a gas. Describe two differences between boiling and evaporation. Okay, so boiling occurs at a fixed temperature, at a specific boiling point. There's a specific boiling point of every substance, but you would never hear about evaporation point of water. So evaporation occurs at room temperature. Next, boiling also takes place throughout the liquid, whereas in evaporation, only the surface particles they absorb energy and they evaporate, they turn into gas. And another difference is a very evident difference. Bubbles are formed in boiling. Next, we already discussed boiling happens at a specific temperature. Name the change of state when a gas becomes a liquid. So when a gas becomes a liquid, it mostly happens when the warm gas molecules hit the surface of hit a cold surface. So the condensation takes place and they turn into a liquid. So condensation. And when a solid directly becomes into a gas without going through liquid state, this is basically known as sublimation. Next, a substance boils at temperature X and melts at temperature Y. Complete the graph to show the change in temperature over time as the substance cools from temperature A to temperature B. Okay, so the substance boils at temperature X and melts at temperature Y. Okay, so the graph would again go like this, and then at Y it will then become a horizontal line. Why? Because whenever change of state takes place, the energy is absorbed by the particles in breaking their bonds, and the temperature stays constant while change of state is taking place. And then when it has melted, so we'll have to go till B. Yeah, so till B. Here boiling takes place. So this means that this above this is it's the gas, and below the boiling point it's a liquid. And this is melting. So this means that above this it's liquid, and below this it's a solid. So at B it is a solid. A solution is a mixture of a solute and a solvent. Name the process when a solid substance mixes with a solvent to form a solution. So dissolving, for example, sugar dissolves in water. Name the type of reaction when two solutions react to form an insoluble substance. This is precipitation. Because a precipitate is formed, this insoluble substance is in the form of a precipitate. Acids are important laboratory chemicals. Some acids completely dissociate in water to form ions. State the term applied to acids that completely dissociate in water. So these are strong acids, and they can also ask you what is meant by strong acids. So you have to write this definition. Complete the equation to show the complete dissociation of sulfuric acid in water. So the hydrogen ion should be dissociated, and the SO4 anion should be, and it has a charge of 2 minus, should be dissociated. As for balancing, we have two hydrogens, so two hydrogens. State the color of methyl orange in sulfuric acid. It is orange in it is basically red in acids and yellow in bases. So the answer over here is red. The equation for the reaction between powdered zinc carbonate and dilute nitric acid is shown. Complete the equation by adding state symbols. So for carbonates, we know all carbonates are insoluble except for sodium carbonate, potassium carbonate. So this is not sodium or potassium, so it will be a solid. And as for acids, these are aqueous. Now nitrates all are soluble. So aqueous, water is a liquid, carbon dioxide is a gas. A student found that 2.5 grams of zinc carbonate required 20 cm cube of dilute nitric acid to react completely. Calculate the concentration of dilute nitric acid using the following steps. Calculate the mass of 1 mole of zinc carbonate. So zinc is 65. Mass of zinc carbonate, and zinc is 65. So 65 plus 12 plus 48 is the MR of zinc carbonate. And we have to calculate the mass. So it's basically N equals to G over MR. So G will be equal to N multiplied by MR, and N is 1 mole. So the MR is the answer. So 65 plus 12 plus 48, which is 1. Zinc is 65, carbon is 12, and oxygen is, we have 3 oxygens. So 16 threes are 48. Have I looked at the MRs correctly? Zinc is 65. So 1 multiplied by 125. 65. Oh, sorry, I got this 48. 125. The answer is 125. Calculate the number of moles of zinc carbonate which are reacting. So we have 2.5 grams of zinc carbonate. So moles is equal to the gram over mr. The gram is 2.5 and the mass is 125 mr. So 2.5 over 125, which will be equal to 0.02. Determine the number of moles of HNO3 reacting. So we have to see the mole ratio, which is 1:2, zinc carbonate and nitric acid. So the number of zinc carbonate moles, if we double that, we get the number of moles of HNO3. So if we double 0.02 times 2, it will be equal to 0.04. Now calculate the concentration of HNO3. So for the concentration, the formula is N equals to Cv, and C equals to N over V, where the number of moles are 0.04 and the volume is, or the concentration, they're talking about the concentration. So we know the number of moles of nitric acid, and what information were we given? We were given the volume. Okay, so 0.04 will be divided by 0.02 because 20 cm cube to dm cube we have to convert it, and for this we divide by 1000. So 0.02, which will be equal to 2. So we just did what they asked us to do and just applied the simple formulas, nothing new. Atoms contains proton, neutrons, and electrons. Complete the table to show the relative mass and the relative charge of a proton, a neutron, and an electron. Okay, so the mass of a proton is 1, the mass of a neutron is 1, and the mass of an electron is this. The relative charge of proton, we know it's 1, neutron is 0, and electron is -1. Now the table shows the number of protons, neutrons, and electrons in some atoms and ions. Complete the table. Okay, so the number of protons in sulfur is 16. The smaller number is always the number of protons, and the number of neutrons is given by the mass number minus the proton number. So 32 minus 16, which will be 16. The number of electrons are the same as the number of protons in a neutral atom, so 16. As for this is a ion. This is a cation. So number of protons do not change. They'll still be 19. The number of neutrons is 39 minus 19, so 20. The number of electrons, we'll have one lesser electron than the total number of protons because of the plus charge. Net charge is plus, so we'll have one more proton than electrons. Now we're given the number of protons and electrons and neutrons of a substance. So this much is certain that it is an anion because this has one more electron than protons. So net charge should be minus. And it has proton number 35. So how much charge it has? It has -1 charge. So this should be in group 7, definitely in group 7, because all group 7 elements have a charge of -1. Number of protons, 35. So the proton number 35 is of what? If you look at this, group 7, 35 is 35 proton number. So 35 proton number is bromine, and we have to write the answer as bromide ion. So Br minus 35, sorry, 44 and 35. Oh, sorry, not 44. The mass number is the sum of these two, so 79. And you can just see it from the periodic table, or it's better you do it from here because maybe this is a different isotope. So you have to, and let me check. Yeah, so you can't see from the periodic table. This is 80. You can't copy from the periodic table in this case because this has 35 plus 44. Bromine has two different isotopes. So this will be 79, not 80. So 79 will be the correct answer and 80 will be wrong. Okay, next. Chlorine reacts with carbon monoxide to produce phosgene gas, COCl2. A catalyst is used. The reaction is exothermic. Explain why the reaction is exothermic in terms of the energy changes of bond breaking and bond making. Okay, so energy changes of bond breaking. Bond breaking requires energy, and energy is absorbed for bond breaking, and in bond making, energy is released. So when in a reaction more energy is released than the energy absorbed, because in every reaction, if you look at it generally, in every reaction there is bond breaking over here and there is bond forming over here. So what makes a reaction exothermic or endothermic is basically the net energy absorbed or released, or the net energy change. And to explain further, a reaction is exothermic when more energy is released over here than the energy absorbed over here. And a reaction is endothermic when more reaction energy is absorbed over here than the energy released over here. So more energy is absorbed in bond formation. Sorry, more energy is released because the reaction is exothermic in bond formation than energy in breaking bonds. absorbed in breaking bonds. Secondly, and then we write bond formation releases energy, and bond, we already have written it, although just for the sake of it, bond breaking requires energy. Releases energy, better. Requires is incorrect. Releases energy. So bond formation releases energy, bond breaking absorbs energy. Oh, bond breaking, my bad. Bond formation releases energy and bond breaking absorbs energy. Okay. Complete the energy level diagram for this reaction. On your diagram, show the product of the reaction. An arrow representing the energy change labeled delta H. An arrow representing the activation energy labeled A. Okay, so this is over here we have the reactants. So and the we know that this is exothermic. Okay, so exothermic is drawn like this. Endothermic is drawn like this. Now this will be the products. Show the product of the reaction, which is COCl2. The activation energy, which is positive always, and it should be from the reactants till the hump, till the peak, EA or A, just A. And the enthalpy change is the this difference, and it is will be negative, so arrow downwards. State why catalyst is used. Catalyst is used to uh, lower the activation energy of the reaction to increase the rate of the reaction. To lower or to increase the rate of the reaction by lowering the activation energy. Describe and explain the effect, if any, on the position of equilibrium when the pressure is increased and the temperature is increased. So let me get this down. So now we have the equation. If the pressure is increased, the side with fewer moles favored and the equilibrium shifts to the side with fewer moles. So which is on the right side, 2 moles over here, 1 mole on this side. So the equilibrium shifts to right hand side, because fewer moles of gas are present on the right side. The temperature is increased, so the reaction is exothermic. The forward reaction is exothermic. So increasing the temperature have will move the reaction backward or will shift the equilibrium towards the left. Shifts towards left as forward reaction is exothermic. Now the thing is that this is in this direction is a forward direction. So this is exothermic, meaning that the backward reaction is endothermic. If the forward is exo, backward is endo. So in endothermic, what happens is energy is absorbed over here, right? So it needs endothermic basically. If we look at it as a whole, endothermic reactions, what happens? They absorb energy more than they release. So it needs to absorb energy. So when we increase the temperature, it is easier for the endothermic reaction, the backward endothermic reaction, to move in this direction. So it shifts towards the left. But when we decrease the temperature, what happens? This endo is not favored and the forward exo is favored. The reaction between chlorine and carbon monoxide can be represented, and when 1 mole of chlorine reacts with 1 mole of carbon monoxide, 230 kilojoules of energy is released. Some bond energies are also shown. Use the information to calculate the energy of the bond between the C and the O in carbon monoxide. Okay, so the energy change is the enthalpy change is 230, and the enthalpy change is basically the energy absorbed mi minus the energy released. Okay, so the energy absorbed, we have 2Cl, we have a Cl-Cl bond, so 240, plus we don't have, uh, we have, we don't have a carbon monoxide over here, so we can't write anything, or we should just write an X, and minus this, so we have a carbon oxygen double bond, 745, plus CCl2, 400s, so 800, and this will entirely equal to be equal to 230. Now, x, if we do the calculation now, 240 minus 745 plus 800 minus 1305. So x minus 1305 equals to 230. Shift on the right side, x equals to 230 plus 1305. So 1535 is the bond energy apparently. So let's go through it again. The bond energy in making bonds is the chlorine-chlorine bond, which is 240. Okay. And sorry, energy the energy absorbed while the bonds are broken is 240, okay, plus X. And we'll minus it from this appears to be correct. Okay. The mistake over here is that this 230 kilojoules of energy is released. So this is the enthalpy change, and because it is released, so it is 230 minus 230 exothermic. So this should be minus 230. Now it makes sense. X equals to minus 230 plus 1305. So minus 230 plus 1305, 1075. So this is the answer. Next, complete the dot and cross diagram to show the electron arrangement in a molecule of COCl2. Okay, so we're given the bonds, a double bond over here. So 1, 2, 3, 4, and the remaining oxygen lone pair electrons, because oxygen has total of 6 outer shell electrons. Here in the sharing one is done by only one pair. Oh, sorry, so only one pair is being shared, so we have more electrons remaining. We have from a total of 6, if we minus 2 electrons, we have still 4 oxygen electrons remaining, which are lone pairs. As for carbon, with chlorine, single bond. Chlorine also has lone pairs. From total of 7, we shared 1 electron of chlorine, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 are lone pairs. Yes. So, yeah. Iron is a transition element. Potassium is a group 1 element. Iron and potassium have the same type of bonding. Name and describe the type of bonding in these two elements. Of course, it is metallic bonding, metals, and what is present is we have positive ions and a sea of delocalized electrons, and there is an attraction between the positive ions. Let me draw this. So these are the ions because they have delocalized electrons, and we have electrons like this, and attraction between these. So we can call it a lattice of positive ions with a sea of delocalized, which are the basically cause of electrical conductivity in metals. Electrons, and there is an attraction, force of attraction between the positive ions and the electrons. Transition elements and group 1 elements have some similar physical properties. They can both be hammered into a shape, conduct electricity, be stretched into wires. Name the term used to describe the ability of elements to be hammered into a shape. So they're moldable, or the proper word is malleable. Describe what happens to the particles in iron when it is hammered into a shape. So the particles slide over each other in a metal, whereas in this is the reason why metals are softer than uh, the alloys. The name just suddenly disappeared. Alloys, because in alloys we have different sized metals, so different size of particles, so they do not slide over each other. So just why copper rather than other transition elements is used for wires which conduct electricity. So because copper, maybe it's, yeah, because copper is unreactive. Copper is the least reactive in the list of transition elements. It is very low down below in the reactivity series. So copper is unreactive. Transition elements are harder and stronger than group 1 elements. Describe how two other physical properties are different than those of group 1 elements. So they are harder and stronger. They have told they have higher melting point, boiling point, higher densities. Chemical properties of some group 1 elements are shown in the table. Okay, so this is available in notes for use in qualitative analysis in your syllabus. So the reaction with cold water is given, and we have to add to the table the flame test colors for sodium and potassium. Okay, so this is given in the table. This is just you can see it from there also. Pure recall and lilac flame for potassium, yellow for sodium, and the predicted reactions of rubidium with water and with oxygen. So the reactivity of group 1 metals increases down the group. So rubidium will react even stronger with cold water as well as oxygen. So it should be explosive reaction. Yeah, reaction with oxygen, explosive reaction, maybe we can say, yeah. Or if they're talking about an oxide layer, so we can say that, yeah, explosive reaction and forms an oxide layer. And as for reaction with cold water, this they were saying steadily effervesces, which means that bubbles are produced somewhat like, and colorless solution is formed. So we can say vigorously or explosively again in this, or we can just describe even more strongly than potassium. So we should just indicate that we know that the reactivity has increased. So more or stronger effervescence or vigorous reaction, vigorously effervesces, and of course forms a colorless solution. Name the gas produced when group 1 elements react with water. So hydrogen is produced. Hydrogen, for example, sodium plus water, sodium oxide plus H2. Name the solution formed when potassium reacts with water. So potassium, sorry, hydroxide, or both. This is, yeah, hydroxide. This is sodium. Name the solution formed when potassium reacts with water. So potassium plus water will produce potassium hydroxide solution. They're saying predict the pH of the colorless solution formed when potassium reacts with water. So it is hydroxide, and so it should be basic hydroxide because it is metal oxide. So pH is greater than 7, so 10, 11, anything. Write the chemical equation for the reaction of sodium with oxygen. So sodium reacts with oxygen to form Na2O. We have two oxygens on the left side, so two oxygens on the right side, and four nitrogens. How did I get this formula? Na had plus 1 charge, oxygen had 2 minus charge, cross multiply NaO. Why it had 2 minus? Because it is in group 6 and Na is in group 1. Iron is a typical transition element. It is a catalyst used in the Haber's process. Write the equation for the reaction that occurs in the Haber's process. Of course, uh, nitrogen plus hydrogen to form NH3, and we have two balancing 3 to the 6. Yeah. So you should be remembering this basically, even without taking too much time. State the temperature and pressure used in the Haber process, include units. So temperature is 450 degrees Celsius and 200 atm is the pressure. You should be remembering all of this, as well as the contact process. Ethanol belongs to the homologous series called alcohols. Write the general formula of alcohols: CnH2n plus 1 OH. All homologous series formula should be in your on your fingertips. Explain why ethanol cannot be described as a hydrocarbon. It does not contain only hydrogen uh, carbon. It does not only contain hydrogen and carbon. Ethanol can be manufactured from different substances by reaction with steam or by fermentation. Give the formula of the substance which reacts with steam to form ethanol. So, ethene. Addition of steam to ethene is the reaction we have studied with the catalyst phosphoric acid. Name a substance which will undergo fermentation to form ethanol. This is glucose. Glucose, and yeast acts on it to make ethanol. Write the chemical equation for the complete combustion of ethanol. So all organic compounds react with oxygen and combust to form carbon dioxide and water. So to balance this, two carbons on this side as well, and six hydrogens on the left side. So six hydrogen on the right side, three twos are six. Now oxygens on the right side, two twos are four, four plus three, seven. So here also there should be seven. So 7/2. Or oh, no, no, no. So seven, there should be total seven oxygens. So we have already one over here. So we should have six more. Ethane 1,2-diol has two alcohol functional groups. One molecule of ethane 2-diol will react with two molecules of ethanoic acid to form molecule X. X has two ester functional groups and a molecular formula. This state the empirical formula of X. So for the molecular formula, just take the simplest whole number ratio, dividing all of these by 2, C3H5O2. C3H5O2. Draw the structure of X. So draw the structure of X. They're saying it reacts with two molecules of ethane dioic acid to form molecule X, and molecule X has two ester functional groups. Okay, it has two ester functional group and a molecular formula this. So six carbons. Of course, it's reacting with two ethanoic acids, so two carbons from here and two already over here. So here the if we draw the acid as well, it has OH. So this OH and H goes away, H2O is formed, and this C directly joins to the O. So this O and then this C, O, C, H, H, H. Similarly over here as well. This was a bit tricky for this should be a little bit tricky. Name the other substance formed in this reaction. We already decided water. Each alcohol functional group in ethane 1,2-diol reacts with acidified potassium manganate to form a different organic product. Why? So oxidation of alcohols produces oxidation of alcohol produces carboxylic acids. Draw the structure of Y. Okay, so ethane 1,2-diol again on both of these places we will have COOH, COOH, and ethane dioic acid will be formed di instead of the diol. So CH, CH, the same, and over here instead of just OH, we should have. Oh, sorry, the OH will remain over here, and we'll have this double bond COOH, and similarly over here COOH. So ethane dioic acid is like this, two functional groups of the carboxylic acids. So the organic part was pretty tricky at this level, dealing with two functional groups at a time, especially in esters and this oxidation reaction. So we've completed the paper. Thank you. Jazakallah khair.